Hello everyone and welcome to this tutorial on manipulator control using moveit. In this tutorial we will learn how to set up graphical motion planning using moveit. To use the GUI that moveit provides, we will need to create a moveit configuration package. And then we will interface the created package with the control package that we have created in a previous tutorial in order to control our robot in gazebo simulation environment using RViz and moveit GUI tools. Before we start this tutorial, we will have to install two packages. The first one, so go sudo apt install ros-melodic, and the first package is an inverse kinematics solver that we'll be using. It's called track IK, I guess. So track IK. You'll need to install this package. And the next one is moveit. So it's the command sudo apt install ros-melodic moveit. So those two commands will take care of installing the packages that we need in this tutorial. And then to create our moveit configuration package, simply we will launch a package called moveit setup assistant, and then the launch file is called setup assistant. This will start a new window and it's pretty simple. We are aiming to create a new moveit configuration package, so click that, and then it will ask us to browse our URTF file where the robot description is stored. So it's in our Catkin workspace as the package, the URTF that we have exported from SolidWorks earlier. Click load files, and here we can see our robot. Next we will go to self collisions, and we will click generate collision matrix. And next step is planning groups. So now we will click at the bottom, we'll click add group. We need to add a name of this group. Let's call it ARM. And in kinematics solver, choose track IK kinematics plugin, which we have just installed. And for the rest, we'll keep it as it is. Except for group default planner, let's select TRRT. So that's it. Now we have our group, and we need to assign joints to this group. So click add joints, and we will start by jarm link 0 till jarm link 5, or plus the base mount, which is the link that is connecting the arm to the mobile base. We don't actually need it. Let's just add the jarm link 0 to 5. So we'll select those, add them here to the selected joints, and click save. And then we'll go to robot poses section. In this section we can create some poses that we can use later in RViz. Click add pose, and let's call this pose 1, and let's keep it as it is, stretched. We'll save that. We'll add a new pose and call it pose 2, and let's move the arm to a certain position. We can maybe fold the arm. So let's say this is our pose 2. Click save. In this case, in this demonstration robot, we don't have an end effector. So in end effectors, we will not select the links that form the end effector. And in ROS control, we can click auto add follow joint trajectory controllers, and the rest we will leave it as it is. We'll go to author information. Let's add a name. ROS tutorials we'll call it, and the email. Then at configuration files, we'll select where we want to generate our package. Go to catkin source, okay, and we will call our package robot moveit. So let me and click generate package. It will warn us that there are no end effectors or virtual joints added. That's not a big deal, but now we can see configuration package generated successfully, and we will exit the setup assistant. That is simply how to create a configuration package. Let's test this package. Start a new terminal, go to catkin, and we'll run catkin make to compile our packages. And now we will source our devel setup and ROS launch robot. We have called it robot_moveit, and we will launch a demo.launch file. So this will start Arvis for us, and we'll take a look at this motion planning window here. You can see that this is the planner that we have selected while creating the package. If we go to planning tab, you can at the start state we'll select current state, and as a goal state we'll select pose 2, the pose that we have created in moveit setup assistant. So let's click plan and execute, and this should move the manipulator in Arvis. So that's simply how to test the package, and we can see that the manipulator is moving. We can also move the manipulator manually and update the current pose and say that we want to move the manipulator here, and a goal pose we will update it again. Plan, I did not update the goal. So plan and execute. You can see you can visualize the plan that the manipulator is going to follow. So next we would need to interface the moveit configuration package that we have here with our simulation environment in Gazebo, and we will do that by referring to our configuration files that we have created previously, and telling moveit which topic it will be publishing on, in order for moveit to control the robot in Gazebo. So let's do that. We navigate to our package, the moveit configuration package that we have just created, and in config folder we need to create 2 new files. The first one we will call it controllers.yaml, and in this file we would list our controllers. So say controllers list. We have name, example URDF, and then we called it ARM controller, and then action namespace is follow joint trajectory, and the type of this controller is follow joint trajectory, and then we need to list our joints. So that will be jarm link 0 to 5. So we'll save this file, and then we need to create a new file. We will call it joints names. And we will simply list our joints in this file. And let's save it. So the next step is we need to edit a file in moveit configuration files. Let me close this. So we need to navigate to our package, robot moveit launch, and we will look for example URDF moveit controller manager .launch.xml. Let's open this one. Let me open it in Visual Studio, and simply we need to refer to our controllers.yaml file. So I will delete the launch file, and we need to list. We need to add our controller.yaml file here. So let me paste it. It's pretty simple. It's a ROS parameter. I've referred to our package and then to the file that we have created, and then we list 3 parameters. So use control manager is set to false, and then trajectory execution is set to false, and last parameter is moveit controller manager. We will set the value to moveit simple controller manager. It's pretty simple. Just copy those lines to and edit the moveit controller manager.xml or launch.xml. And the last step is creating a new launch file. So in the same directory, start a new terminal, and we'll create this new file. Let's call it example moveit.launch. So this file will start a joint state publisher node. It's pretty simple, and we will refer to the joints list, or the topic that we are going to be publishing the joint states on, which is the topic that we have created previously. And then we will include move group and rviz launch files, which were created using moveit setup assistant. So it's a pretty simple file, nothing new. And let's go and test this package. So we will launch our simulation in Gazebo first of all. So ROS launch example URDF Gazebo, and then in a new tab, ROS launch robot moveit, and then example moveit. So let me arrange the windows first. And zoom into our robot. Then launch the launch file that we have created. So here let's add a motion planning and set the fixed frame to base footprint. So it says yes. Now that it did load the planning library, we can test a plan from the current position. to the pose that we have created previously. So plan and execute. Oh, actually, that's a good coincidence. The arm is not moving in Gazebo because we cannot find the controllers. It says that moveit is unable to identify any set of controllers, and that is because I did not launch the example control package. Now that I did, I hope that it will execute it without having to restart it. I think I have to restart Gazebo and Arvis. So let me do that quickly. So we'll start the Gazebo package, and then we need to run the controller package first of all before starting the moveit configuration package. And now that we see that ARM controller is started, we can start the example moveit launch file. And I will move Arvis here, add motion planning, and change the fixed frame to base footprint. And I will plan from the current pose to pose 2, the one that we have created while creating the configuration package. So I'll hit plan, execute, and you can see the movement in Gazebo. So that's it. I hope that it wasn't too complicated. It's too many steps, but if you take those steps one by one and try to understand them, it's not a lot of work. To review that, we have created we have added transmission and Gazebo control plugin in the URDF, and then we have created some configuration files in order to create our topics. Then we did create moveit configuration package and edited the controller launch file in order to reference our new topics. And that's it. Moveit is able to publish on the topics, the control topics that we have created earlier. So that's it for this tutorial, and I will see you in the next one.